Hello students, welcome back. So in this session, we are going to be learning about DBSCAN. DBSCAN it stands for Density Based Spatial Clustering of Application with Noise. Oh my god, that's a mouthful. In DBSCAN, what you do, it clusters data point based on their density and it identifies outliers as points that do not belong to any clusters. In other words, your DB scan it labels points that do not have enough nearby points or nearby neighbors as your outlier. So for example, let's take a look at this one. This one do not have enough neighbors. This one also does not have enough neighbors. Not enough, not enough, not enough. So these would be your outliers. Now DBSCAN, it has two parameters. The first one is your epsilon. The second one is minimum points. Your epsilon, it determines your neighborhood radius. In other words, it tells you the maximum distance to consider in order to find neighbors. So think of this as a circle around a point. Suppose this is your point right here. And your epsilon is some number. Let's say this is zero point 0.5, zero point 0.6, could be any number. So in this case, you draw a circle like this of that radius. So the reason you draw the circle is because you're trying to find out how many points are closer to me. So any point that falls inside this radius, they are your neighbors. So in this case, this is a neighbor, this is a neighbor, this is a neighbor, this is a neighbor of this point. These 2 points are not neighbor. This is not a neighbor. And then you have minimum points. Well, this actually is the minimum number of neighbors that is necessary in order to form a dense region. So let's take a look at this example. This is my point right here. And let's say my epsilon is this. So you know your epsilon, draw a circle like this. And then you ask yourself that in this case, my minimum point is 5. Do I have at least 5 points over here? And the answer is yes. 1, 2, 3, 4, 5. You have at least 5 points within the radius of epsilon. So this would be your dense region. Let's take a look at this one. Same epsilon, you draw a circle around this point. That would be this point right here. When you draw the circle, you ask how many points are within this epsilon. In this case, there's only 2 points, 1 and 2. And the minimum point you need is 5. So this is not a dense region. Now the question is, how do you find these minimum points? Well, these are the rough guidelines. Your minimum point should be greater than or equal to the dimensions plus 1. So this is one example, one guideline that you can use. For example, if you have three-dimensional data, let's say take a look at this one. You have a transaction time, transaction amount, and what type of the card that was. So let's say you have this data and you have three features over here. So this is a three-dimensional data. So in this case, my minimum point is going to be either 4 or 5. So your 3 plus 1 is 4. So take 4 or 5. Another one you can use is minimum point equal to 2 times the dimension. So if you have a three-dimensional data, let's say this one. So in this case, your minimum point is going to be 2 times 3, and the answer is 6. In other words, the more dimensions you have, the more minimum points you're going to have. Now the question becomes, how do you choose this epsilon? Well, we use something called elbow method. And the way it works is like this. Suppose you choose k equal to 3. You always start with k. You have to pick up your k. So in this case, let's say I pick my k as equal to 3. Now for every point, you find the distance to the k nearest neighbor. In other words, you ask yourself for every point, like how far that point must go to find the k neighbors. In other words, 3 neighbors. Then, once you've determined that, you sort the distance for every single point. And then you plot the points with the k distance. So let's say when you plot it, it will come out to be like this. This axis would be your points sorted by distance, and this one would be your k distance right here. Now, when you look at these points, these are the ones, these points, they have a high k nearest neighbor. In other words, your k nearest neighbors are very far for these points right here. On the other hand, well, the reason is because if you look at this one, this right here is basically in this axis, and this is my k distance. So k distance is higher over here. So this is why these points have k nearest neighbor very far. These ones, on the other hand, your k nearest neighbors are not very far. They are close by. So for example, if your k equal to 3, then your k distance is going to be between 0 to 0.5 for these set of points right here. In this set of points right here, my k distance is going to be between, let's say, 0.5 to 2.5. Now, why did I pick up 0.5? Because this right here is my elbow. So if you look at this graph, look at this curve right here, it goes like this. And if you just take a look at it, I would say the K, or I'm sorry, my elbow, it falls over here. So you just come this way and you look at this value, and this one is 0.5. So this is my elbow. So let me just write over here 0.5. So all the values that are in this region right here, here my K distance is going to be between 0 to 0.5, and all the ones in this region right here, my K distance is going to be between 0.5 to 2.5. So these points that falls in this area, these are good candidates for outliers. An important point to consider, your DBSCAN is a distance-based algorithm, and because it is a distance-based algorithm, you want to make sure that you scale your data first. So some of the interesting applications of DBSCAN would be in fraud detection, network intrusion system, in your sensor anomaly detection, any points that are basically are outside the normal. These are some of the simple application of your DBSCAN. Customer behavior analysis, also for spatial and geographical data. So these are some of the interesting applications. So the DBSCAN algorithm. Step one. First, you want to mark all the points as unvisited. Suppose I start with these points right. This is my original data set. So from here, you come over here. You mark every single point as unvisited. So that means unvisited, 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 and unvisited. Step two, now you randomly pick an unvisited point. Suppose I pick up this point right here. This is my random point I picked up as unvisited point. We are going to mark this as visited. So I'll put this thing as V right here. Next step, now you find the neighbors. So this is my point. That is, I just marked it visited, and you draw a circle of radius epsilon, and then you find how many or what points lie within this radius, and that would be this point and this point. So the neighbors for this one is this one and this one. And now you perform the density condition check. So there are two cases. Case one, you do not have enough neighbors. Now, how do you decide that? Well, remember the minimum points we picked up. So you check how many neighbors do you have. If your number of neighbors is smaller than number of minimum points, then you're going to mark that as a noise. So in this case, let's say my minimum point is 3. If the minimum point is 3, this is going to be marked as a noise. On the other hand, if my minimum number of point, let's say, is 2, then this would not be a noise. This would be a core point. This would be your case B. And the next step is that you are going to be expanding the clusters. And the way you do is like this. For each neighbor Q, in other words, for this one, let's say this is my Q, next Q, then for each one of the neighbors of this point, if this neighbor has not been visited, okay, then you are going to visit it. In other words, you're going to mark it as V. And then you're going to find the neighbors of Q. Same method, you're going to draw a little circle around it. Okay. Now, if your Q has if the queue has neighbors, okay, which is greater than the minimum number of points, then you're going to merge those neighbors. In other words, your clusters, it grows. And then you are going to assign Q to the new cluster. And then you keep doing this thing. This process, this expansion, it continues recursively. And then the next step, we keep continuing this process until all points are visited. In other words, all points are marked as visited. This one is visited, 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 visited. Everything has been marked. Then step 7, now you perform your final outlier detection. After the clustering is done, you check the points that are not assigned to any clusters. Those would be your outliers. In those cases, your label are going to be -1. So those are your noise. In this case, this might be my noise. Now let's look at the code of DBSCAN. From my sklearn, I'm importing DBSCAN. I'm also importing make blob. So this is going to be responsible for creating your data set. So first thing I do, I create a data set. I'm creating 300 samples, and I want 3 clusters. And then I print out my data set. So I'm just printing out the last 5 records just to see how exactly it looks like. Sorry, the first 5 records. So just to show, just to see how exactly it looks like. So these are my first 5 records. The first one, second one, third one, fourth one, and fifth one. So it only has 2 features, 2 columns. And then I want to plot them just to see how the picture looks like. So this is the When I plot it, this is how it looks like. So you can see that it has three clusters right here, and you can see that there are, this one should be outlier, this one should be outlier, this should be outlier, and this one should be outlier, and I think this might be one too. All right. So first step we do is find our epsilon. Now from my scikit-learn library, I'm importing nearest neighbor. I'm also importing numpy. And I specify my nearest neighbor as k equal to 3. By the way, this should be same as the number of minimum point you're going to be specifying in your DBSCAN. So make sure of that. So compute your nearest neighbors. So in this case, you call your nearest neighbors and you give your nearest neighbor as k equal to 3. That would be this right here. And you train your model. And then it's going to print, it's going to find the distance and indices for each one of them. So what I'm doing, I'm taking the kth distance. In other words, I'm finding out how far is the kth nearest neighbor. That's what this k distance is. So it basically gets that information. And then I'm sorting them out for every single point. So this one is telling the kth distance for every single point. So this is actually going to have 300 distances because there are 300 points. Right here, I actually create 300 points. So it will have 300 distances, 300 k nearest distances. Okay, then I sort the distance and then I print out the first 10 and then also printing out the last 10 just to show you. So if when I print out the first 10, look at that, it's very small. Okay, so k nearest neighbor, I mean k nearest distance is small. But when I print out the last 10, you can see that your distance are large. So the one that are close, okay, the first ones, they are basically small distance, and the one that are very far, okay, these are like large distances. Then I plot them. I give k distance, and when I plot them, this is how my k distance plot looks like. And you can see that your elbow is somewhere over here. So in this case, I would pick up like 0.5. That seems like a right number. So 0.5 is my epsilon. So coming down over here, I am calling DBSCAN. I supply my epsilon 0.5. My minimum number of samples, I specified 3. And labels db.predictx. Find your outliers. So anything that has a label equal to -1, they will be outlier. So basically, I'm just extracting all those values that have label equal to -1. And then I'm plotting the number. So I plot my x. This is my first feature, second feature. And I'm also plotting my outliers on top of that. And outliers, I'm putting color yellow. And as you can see, it plots this thing. And you can see that these are my outliers. This one, this one, this one. These are my outlier points. All right, it did a good job. Now I want to see my outliers. So just write outliers and that's going to print out your outlier points, all of them, these right here. So I would suggest come over here and in this notebook, try to play around, try to change the minimum sample to 3, 4, 5. So make sure that whatever you change, you also change this right here too. So if you change that to 3 or 4, make sure you change that too. Because your epsilon actually should, this one is controlled by your minimum point. So this should be the same.